One of the conics that we look at is the parabola. The parabola is created when you take your cones, which we've already discussed, and stack them, tips together. And when you slice, you hit one cone but not the other. So we get just this little piece here. And this is similar to the parabola where we have a quadratic function creates a parabola that would open up or down. But in this case, we can also open right or left, so it wouldn't necessarily be a function. So the parabola has a vertex. It has a focus. It has a directrix, which lies on the other side of the center from the focus. And notice our parabola curves around the focus away from the directrix. And then it has the axis of symmetry that goes through the center or through the vertex and the focus. So you've got your two situations here. This distance between the vertex and the focus, or between the vertex and the directrix, is P. So the distance between the vertex to the focus and the vertex to the directrix is the same, and we call that P. So the standard form of an equation of a parabola with the vertex at the origin, the first situation where the axis of symmetry is along the x-axis, then we have y squared equals 4px. In the second situation, our axis of symmetry is along the vertical axis, so we have x squared equals 4py. Okay, so it's kind of opposite here. If we're along the x-axis, then we start with y squared. If we're along the y-axis, then we start with x squared. The latus rectum, I know that sounds odd, is a way we can find 2 points to help us graph our parabola. 2 points other than the vertex and the focus. The latus rectum is on either side of our focus. So if our focus is there, then going up to the parabola and down to the parabola would give us our 2 points. And both those distances are 4p. So that's going to be useful to us to find those 2 points also. Example 1 says, find the focus and directrix of the parabola, y squared equals 8x. Find its endpoints of the latus rectum and graph the parabola. So the first thing we need is the center. Well, the center is at 0, 0, because there's nothing with h and k going on here. The second thing we need to do is find p. So what we do to find p is we take the number in front of x there, that's 8, and set it equal to 4p. Why do we set it equal to 4p? Because 4p is what's in front there. So since we've got y squared equals 4px, and this is y squared equals 8x, then 4p is equal to 8. 4p is equal to 8. So p is 2. What does this tell us? Well, first of all, one more thing we need to identify. Where is the axis of symmetry? Is the axis of symmetry horizontal or vertical? Since we started with y squared, then it is horizontal. So that means that P goes to the right of our vertex and to the left of the vertex. Now, one of those is the focus and the other one is the directrix. Which is which? Since this is a positive 8x, then that means that our parabola opens to the right. Which means that this one, if it's going to open to the right somehow, then that one on the right is our focus. So the focus is at 2, 0. So the other one, the one on the left, will tell us where our directrix is. Our directrix is x equals -2. Now we're almost ready to graph this, but we need to find our 2 points. In order to find our 2 points, that's going to help us find our latus rectum. Our 2 points, we're going to plug in the x value of our focus to find our 2 points. So it's going to give us a point up here and a point down here to help us graph. So we've got our equation is y squared equals 8x. So we have y squared equals 8 times 2. This should be an 8. So y squared is 16, which means y is plus or minus 4. So our 2 points would then be 4 above our focus. That's the point 2, 4, and 4 below, so the point 2, -4. And now we can draw our parabola. Moving forward, find the standard form of an equation of a parabola with a vertex at 8, 0, and the directrix x equals -8. So the focus is at 8, 0, and the directrix is at x equals -8. So that means that our center must be at 0, 0 because it's halfway between the focus and the directrix. And if that's the case, then our axis of symmetry is horizontal. Because it's going through the vertex and the focus. And by the way, I put center there. That should be vertex. Okay, so that means if our axis of symmetry is horizontal, then we're using the equation y squared equals 4px. Well, we need to find P. P is the distance from the center to either our focus or our directrix. So this distance would be 8. So we can plug in 8 for P And so the equation of our line must be, or of our parabola, must be y squared equals 32x. And without finding the latus rectum, which would be way off the page, it looks something like this, but it didn't ask us to graph it, so I'm not too worried about that. We just wanted to find our equation. There it is. And we used the graph to help us. What happens if your vertex is not at the origin? Well, then we call the vertex HK. You can see that you've got some formulas here for the focus, for the directrix, depending on whether your axis of symmetry is horizontal or vertical. And you can use these formulas to help you, or you can use the graph to help you, or a combination of both. So let's look and see what we've got here for the first example. Before we do that, you can see that if the vertex is at HK, then the distance from the vertex to the focus is P. So the point for the vertex would be H plus P, K. And then for the directrix, the distance from the vertex to the directrix is P. So the directrix would be X equals H minus P, because you're going to the left. If it opens to the left, opposite way, or opposite information there, you would have the focus would be H minus P, K, and the directrix would be X equals H plus P. If your parabola opens up, then this distance is P, so your focus would be at H, K plus P. If it opens down, it would be H, K minus P. And then same thing for the directrix. It would be Y equals K minus P if you're opening up, Y equals K plus P if you're opening down. And all that's spelled out for you on here. And one thing, you don't really have to remember if it's a plus or a minus in here, because if you're opening to the left or down, then P is going to be negative. So that's going to determine that. Example 3 says, find the vertex, focus, and directrix of the parabola given by x minus 2 squared equals 4 times y plus 1, and then graph it. First off, what's the vertex? Well, it's the opposite of what's in here, so it would be positive 2, negative 1. So let's start by graphing that. There it is. Which way is this opening? So, the axis of symmetry, since we're starting with x squared equals, then that means the axis of symmetry is vertical. Then, since this number is positive, then that means our parabola must open up. Okay? Next step, find P. So remember, this number is equal to 4P. So to find P, we'll say 4P equals 4. So P is 1. What that tells us, since our parabola opens up, is that our focus is 1 up from the vertex, and our directrix is 1 down from the vertex. So that means our focus is at 2, 0. And our directrix, we said, is at y equals -2. The last thing that we need here is our 2 points. So we can find our 2 points by using our equation. And plugging in, let's see, they need to be here and here. So that's where y is 0. So plugging in y equals 0 into our equation. So we've got x minus 2 squared equals, that'd be 4 times 1 or 4. Take the square root of both sides. So we've got x minus 2 equals plus or minus 2. So our points will be x minus 2 equals -2 or x minus 2 equals positive 2. Add 2 to both sides. And so our 2 points will be at 0, 0, and 4, 0. And now we can graph our parabola. Something like that. Let's look at another example. In this one, we've got, find an equation of the parabola where the vertex is at 1, -2, and the focus is at 2, -2. Let's look at the graph to help us out. So the vertex, we said, was at 1, -2, and it says the focus is at 2, -2. So that tells us 2 things here. That tells us that our axis of symmetry is horizontal because it has to go through the vertex and the focus. And it tells us that the parabola, since it curves around the focus, it has to open to the right. So that means we're going to use the equation. Since the axis of symmetry is horizontal, we start with y squared. So y minus k squared equals 4p times x minus h. And we plug in. So y minus k was -2, so plus 2. Squared equals 4 times p, we'll come back and find that in a second, times x minus h, which was 1. So let's find p. Looking at our picture here, we can see p is the distance between our vertex and the focus, so p must be 1. So we'll just put a 1 in there. So simplify real quick. We've got y plus 2 squared equals 4 times 1, which is 4, times x minus 1. Now, I just want to point out, since we're probably not going to look at an example like this, how do we know if this number is negative? Well, if it turned out that don't write this down or anything, that our focus was over here, so open to the left, then that would mean that P is, since it's going to the left, P would be -1. Okay, and that would make our equation negative there. I just wanted to point that out. Okay, so we found our equation. It wants us to graph it. If we're going to graph it, then we need to know 2 points. So to find our 2 points, we need to plug in where x is 2. So 4 times 1 is 4. So that'll be y plus 2 equals the square root of 4, which is plus or minus 2. So -2, or y plus 2 equals +2. So y is -4 or y is 0. So our 2 points would be at 2, -4, and 2, 0. And that enables us to graph our parabola. We could also put our directrix in here. The directrix is P distance from the vertex over to the left. So the directrix would be x equals 0. Another example. I know this makes the notes really long, but I feel like if we can do as many examples as possible, the more you'll understand it and be able to do your assignments. Okay, so we're going to write, first of all, this equation in standard form, because we can't graph it like it is, and then we'll graph it. So, we have got 4y squared plus 12y plus 16x minus 71 equals 0. Since I see the y squared here, then that's where I'm going to be completing my square. I don't need to mess with anything for the x because I don't have an x squared. So just the y's. So we've got 4y squared plus 12y. And then I'm going to get let's not even worry about the parentheses. I'm going to take the 16x and the 71 over to the right. So subtract 16x from both sides, add 71 to both sides. Now we're going to complete the square with the 4y squared plus 12y. Before we can complete the square, we need to factor out a 4. And we're going to be adding something in there. Since we've factored out the 4 and we need to add something, that something on the right side too, we'll need to do 4 times that something on the right-hand side. Okay, what will the something be? Well, remember you take b over 2 and square it. So that would be 9/4. Factor y plus 3y plus 9/4, you get y plus 3/2 squared. Notice it's always, this number is always this number before it's squared, or b over 2. And over on the right, we've got to take 71 and add to it 4 times 9/4, or in other words, 71 plus 9, that's 80. Now we're not quite done, because if you'll notice, on the right-hand side, it's not in the form where we've got x plus or minus something in parentheses. So, and then on the left-hand side, we've got a 4 sticking out front, which isn't allowed. So let's start by getting rid of that 4 out front here. So we'll have y plus 3/2 squared equals negative 4x plus 20. And then last, we need to get this where we've factored out everything and left x something plus or minus whatever it is, something there. So we can factor out a negative 4. And if you take negative 4 out of 20, that leaves us with minus 5. So here's our equation now. In standard form, it's y plus 3/2 squared equals negative 4 times x minus 5. It asks us to graph it. So, where's the vertex? The vertex will be x, y, hk. So x would be positive 5. Y would be negative 3/2. And actually, x is negative 5 because I said this was... I've got something off there. Hang on a second. Okay, back up. That was a minus x minus 5 there. So the vertex is at 5, negative 3/2. Which is off my graph because I figured it wrong when I was doing this originally. So let's see. Let's extend our graph a little bit here. So there would be 4, 5, 6. I think that'll be enough. So the vertex at 5, negative 3/2. So that's 5, negative 1.5 right there. Okay. Next step is to find P. So 4P is this right here, negative 4. So that means P is negative 1. So two things we found here. First off, since P is negative 1, then we've got to open left or right, or excuse me, left or down. But where is our axis of symmetry? Since we've got y squared first, then our axis of symmetry is horizontal, which means we must open left. So if P is negative 1, then our focus is going to be to the left of our vertex, 1 point. And then our directrix will be 1 unit to the right of our vertex. So that makes our focus at 4, negative 3/2, and our directrix at x equals x equals 6. The last thing we need is just our 2 points. Seems I've run out of space here. Let's move things around a bit. Okay, so to find our 2 points, we need our standard form. So that was y plus 3/2 squared equals -4 times x minus 5. And we're going to plug in, we need it to be up here and down here. So where x is 4. So 4 minus 5 is -1. And -1 times -4 is 4. Take the square root of both sides. So we got plus or minus 2. So our two equations would be y plus 3/2 equals -2, or y plus 3/2 equals +2. So in both cases, subtract 3/2. -2 minus 3/2 is -3.5. And 2 minus 3/2 is just 1/2. So our 2 points then are going to be where x is 4 in both cases, and y is -3.5 and 1/2. And now we can graph our parabola. You could find some more points if you want to, but it's not required. One more example, and this is example 6, not example 5, if it matters. It says an engineer is designing a flashlight using a parabolic reflecting mirror and a light source. So it's kind of like a shade of sorts with a light inside. The casting has a diameter of 6 inches. So 6 inches along the top. And a depth of 4 inches. So kind of like a lampshade with a diameter of 6 inches and a height or depth of 4 inches. What is the equation of the parabola used to shape the mirror for this flashlight? At what point should the light source be placed relative to the mirror's vertex? So, in order to talk about this, the easiest thing for me to do is to graph it. So we're going to put the vertex at the center, because why make it more difficult? And we know that from the vertex, which if I draw it on our picture, it's right there, then one of our 2 points is 3 this way and 4 up. So it's at the point 3, 4, right there. And the other one is 3 to the left and 4 up. So -3, 4. And so here is our lampshade, or the mirror for our flashlight. Okay? We want to be able to write that equation. So we know that it opens up. And since it opens up, that tells us that the axis of symmetry is vertical. So we're going to use the equation where we've got x squared first. X minus h squared equals 4p times y minus k. Well, since the center's at 0, 0, then we can get rid of the h and k. So x squared equals 4p k, or y. Okay, we need to find p. In order to do that, we know two of the points on our graph. One of the points is at the point 3, 4. So if we plug in 3 for x and 4 for y, then that will allow us to find p. So p is at 9/16. So the equation then would be x squared equals 4 times 9/16 y. And go ahead and multiply. 4 times 9/16 will be 9/4. So x squared equals 9/4 y is the equation for our mirror. And it says, where should the light be placed? Well, since P is 9/16, then let's see, where is 9/16? It's a little bit over half. So it's on the inside of our parabola, up right there. That's where the light would be. And so that would be the point 0, 9/16. And that concludes our section on parabolas.